Hi, class. Before we get started, I just want to go over an idea that you should be familiar with, but it's going to be very important in being able to understand the work we're going to be doing. And so, what I want to talk about is squaring numbers. So, if you don't mind, I'm just going to put a few numbers down here, and then we're going to square them. So, I'm going to put it right here under the where the name thing goes here. I'm going to put it 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11, and 12. And so what I'm going to ask you to do is to square all these numbers, because there's a certain group of numbers that we're going to need to become familiar with. So 1 squared, of course, is just 1. In fact, let me just go ahead and change the color of my pencil so we can distinguish between the two. So 1 squared is 1. 2 squared is 2 times 2, which is 4. 3 times 3 is 9. 4 times 4 is 16. Now these numbers in red are numbers that were going to be very important in this next unit. 5 squared is 25. 6 times 6 is 36 and 49. 64. Then 81. 100. 11 times 11 is 121. I don't know if you remember that. And then 12 times 12 is 144. And what we're going to be using is, so we do know how to square numbers, to multiply them by themselves, but what we're going to be talking about today is what happens when we to undo the square. And we call the undoing of the square this thing called square root. And a couple examples of square roots would be square root of 36. Square root of 36, we use this thing called radical 36. It asks the question, what number times itself is equal to 36? The answer is 6. Another radical, radical 49. All right, looks like a little bit of a division sign, but not really, because it's got that little hook in the beginning, little j in the beginning. But square root of 49 is equal to 7. And we can square root all those numbers, but those numbers that we're dealing with in red are called perfect squares, and they're going to have a special place in our work coming up. So see if we can't remember those, especially those first few, I'd say definitely up to 10, being able to be familiar with seeing those numbers. So let's go to the first part of this, and the first part of the work we're going to do is talk about what does it mean for an expression to be in simplest form, a radical expression. And let's go ahead and read them quickly. So it says a radical expression is an expression that contains a radical, which we just talked about. An expression involving a radical with an index n, in the index for our purposes is always going to be the 2, which we typically don't write. So radical 2 is the same thing as just square root. These are identical. So anyway, we're not going to be dealing with that too much. It's in simplest form and the 3 conditions are met. No radicand has a perfect nth power in the factor other than 1. So for our purposes, that just means there's no perfect squares as factors in the number. I'll show you that in a moment. And there's no radical that contains a fraction. So no fractions in the radical, and I'll show you that in a moment. And no radicals in the denominator. That's a key piece too. So let's look at a few pieces. One of them here is, let's look at the first number 19. Square root of 19, sorry about that. Square root of 19 is in simplest form. So it is, so I'll give it a quick check, because there's no perfect square factor inside there, and it is not a fraction. Let's look at number 48. Now you may notice that inside 48 there is at least a number 4, right? In other words, if I multiply by 4, I get if I could rewrite this, I could rewrite this as 4 times 12. And there's actually a perfect square in the 12, but we know that 4 is a perfect square. It's 2 times 2. So anytime there's a perfect square as a factor inside, it is not in simplest form, and we'll have to reduce it. We'll have to simplify it. In fact, there's even a 16 inside that 48, but we'll talk about that later. So this one is not simplified. How about this one? How about 5 over root 2? Well, whenever we have a radical in the denominator, that also is not fully simplified. Another question says, is the radical, is a fraction, is there a fraction, radical, I'm sorry about that. Does the radical have a fraction inside of it? That's 1 over 17. That would also not work. 34. Now, 34, is there any perfect square that goes inside there? Well, sometimes one of the ways we can determine that is we can just take it and prime factor it. We have 17 times 2. Well, it looks like that's as much as we can factor it. Neither one of those numbers is a perfect square, so we will say that this one is in simplest form. Last question is there's a few things to look at. First, the 4. It's not a radical, so that's okay. Is there a factor of 10 that's a perfect square? Well, 10 is just made up of 2 and 5, and if you look up on the top, none of those red numbers are 2 or 5, and so that's okay too. And this 3 here, so this is clearly in simplified form also. So we only had 1, 2, 3 in simplified form. The others, the other ones were violated the rules. So anyway, moving from that idea to our first topic on the next page. Let's go ahead and turn the page. If you printed this, you should have your notebooks out, if nothing else, or this page printed out so you can practice. So now we're going to take some of these ideas and I'm going to show you if things are not simplified, what to do. So here is the number 108. So at this point, you're going to need to get your calculator out and see if you can't find what is the largest number that we can divide into 108. So if you take your calculator, take your 108, and you divide it by 4, well, believe it or not, that actually will work. But let's see if there's a bigger number that you can divide into the 108. Let's try 9. 9 into the 108. 9 also goes into the 108. So let's keep going though. What's our next biggest number is 16. If you remember from the other side, actually I'll go ahead and write these perfect squares down. We have 1, 4, 9, 16, 25, 36, 7 times 7 is 49, 8 times 8 is 64, and 9 times 9 is 81, 10 times 10 is 100, and we'll keep going from there. But anyway, what we're going to be trying to do is to locate the largest number that goes into the 108. 4 does go in, yes, and the 9 also goes in. 16 does not. 25 does not. And interestingly, though, 36 does go in there. 36 goes into 108 3 times, so that happens to be the largest perfect square that can go in. So 36, so I can rewrite this number as the square root of 36 times the square root of 3. And the square root of 36, we already know, is 6. And the square root of 3 just stays right there. It's going to be 6 square root of 3. Very good. All right, so let's look at number. Let's go right now to do a couple practice questions. Number 24. What I'd like you to do right now is to divide all the numbers you can. Now, of course, you can't divide it by 25, but you can see if 4, 9, or 16 goes into 24, I mean. And I'd like you to do number 1, and I'd like you to do number 2. Now, don't worry about this minus sign. That minus sign is just going to carry through to the final answer. And but like right now, I'd like you to try number 1 and number 2. Okay, let's see how good you did anyway for the 24, the largest number that goes, perfect square that goes into 24 with your calculator out would just be 4. So we can rewrite that as square root of 4 times square root of 6, or 2 root 6, 2 times the square root of 6. The 80, surprisingly, there was a 60 that goes into that, 16 that goes into that. That negative 16, negative root 16 is the same thing as the negative 4 and the root 5. We can not do anything with that. Okay, though, now let's go up to B and see how we deal with that one. Now, B, first of all, we have square root of 9, which we know is 3, so we can take that out, the square root of 9. Now, what do we do with the x to the third? Now, watch this trick. I'm going to call this the square root of x squared times the square root of x. Well, there is a square root of x squared. What number times itself equals x squared? Well, that answer is x. Square root of 9 is going to be the 3. And the square root of x, well, there is no number times itself that equals x, so that just stays here. So we can take the square root of variables too. And let's go ahead and take a look at number 3. See if you can't do number 3, and I will do number 4 after that. So let's take a pause and do number 3. Okay, you can check your answer. What I did is I broke things up. 49 has a perfect square, which is 7. And then I took that x to the third and I rewrote it as x squared, square root of x squared, times the square root of x. And of course, just like I said, square root of x squared is x. Square root of x, though, can't be changed, and so we just end up with 7x root x. Now, number 75, this number 4, is going to be a little bit trickier, but let me show you how this one works. We're probably not going to get too many like this, but if you can understand what I do here, then you're in good shape. The largest perfect square that goes into the 75, I know for a fact, is the square root of 25. And that's going to be 25 times 3. So square root of 25 times square root of 3 that gives me the 75. And then I can take n squared. There's 2 n squareds in there that I can take out. And that leaves me with just 1 n left. So you see n squared times n to the 1 gives me my n to the 5th. So this is an equivalent expression, this big blown up mess that I just made here. But this big blown up mess can be simplified. I can take this square root of 25 and I can make a 5 out of it. Let me get all the square root numbers first, put them together. I can get an n out of here, and I can get an n out of here. But the numbers that can't be I can't simplify is the square root of 3 and the square root of n. So what do I do with those? Well, let me just go ahead and simplify this whole thing. This is going to be 5 n squared, and 3 times the square root of n is actually the square root of 3n. So that's beyond what you're going to see for homework, but if you can understand that, you're certainly in a very good place. And if you have a chance, maybe you could replay that and take a look at it. Those are the kinds of questions you're going to see in Algebra 2. Well, anyway, let's take a quick look at what's coming ahead. Is in example 2 is another level of simplification that we need to do. And let me go ahead and do that for you. And so let's go ahead and start with with A. First thing we're going to recognize whenever we have a radical over a whole fraction is that we can divide it up. We can take it as a radical 15 divided by the radical 64. This is a property of radicals. It's very helpful that anytime we have a fraction in a radical, I can break the radical up into the numerator and denominator. And of course, the 64 has a perfect square root. Do you remember what it is? It is 8. And now this fraction is simplified and we've reduced it, and that's the answer. Let's go ahead to B. Again, we can break this up to the square root of 81 over the square root of x squared. And as you guys remember, square root of 81 does have a perfect square, is a perfect square root of 81 is 9. And square root of x squared is just going to be x. And so that one's done. So now what I'd like you to do is, these are a little bit easier than the ones we did before, but let's go ahead and take a moment and see if you can't simplify these 4 questions. Okay, and if you pull this off, you're in a great place, especially number 8. Number 8 was pretty tricky. I'm not sure if anyone got that one, but the first one reduces to the square root of 23 over 3. Number 6, negative square root of 17 over square root of 100. The square root of 100 reduces to become 10. And on number 7, square root of 36 over square root of z squared just reduces to 6 over z. And number 8, that was a tricky one because now we have the square root of 4x squared over the square root of, I forgot to put that in there, the square root of 64. And the square root of 64, okay, I wrote that one wrong. Let me redo that one now. Thank you. All right, so if you caught me getting that one wrong, that would be even better. But let's go ahead. So the square root of 64 is just going to be 8. And that does reduce to, you can reduce this by the 2 and the 8 by 2, and you just get 1x over 4. And there you go. If you pull that one off, you're in a great place. So at this point, you guys are free to go and try the homework assignment. If some of this didn't make much sense to you, I would think that it might be worth going over it again. It's not a terribly long video, just to make sure that you understand this. You're going to be visiting this stuff in geometry next year, or for some of you, or for many of you, it looks like you're going to be looking at some of this stuff during the summer. So you're going to be playing with more radicals at that point. Okay, well, good luck to you on, again, you do not, if you did this video, you recognize that this is the only thing that's due for you for our next meet session, and at that meet session, we can tackle the homework, if you will. If you wish to, you could go ahead and try to start it early. That may be something that you'd like to do. Guys, take care, have a great day, and we'll see you soon.